Okay, so let's wait for everybody to kind of get replaced, and I think Joan did a nice job of showing everybody the mix of folks we have in the room. We definitely will need to be more on first name basis for design thinking, because empathy, it's important that people will who know who you are and where you're coming from, and where you're going, where you think you're going anyway.
Right.
And so I don't know, let's see, we're still kind of got people dribbling in, I think. So let's start over here. So just tell your name and what company you're from, and then we'll just go around the room, and just so everybody has a kind of a sense of who everybody is.
First names.
Yeah, first name's fine.
I'm Jill. I'm with Farmers Union Insurance.
My name is Glory, and I'm with Center Mutual Insurance.
My name's Hannah, and I'm also with Center Mutual Insurance.
My name's Rob, and I'm with Center Mutual Insurance.
Brandon Sorensen with Farmers Union.
I'm Scott Morris with the NEIC.
I'm Ryan Drager from Dundee Mutual Insurance.
Chris Linsett, the Nordac Insurance.
Mason, Nordac Insurance.
Lisa Strom, Southwest Mutual Insurance.
Brad Shamlack, Walsh County Mutual Insurance.
Hi, Dorman Bazell, Chief Data Officer for North Dakota.
Leah Huntley for NDIT North Dakota.
Wonderful.
Derek Lyons, North Star Mutual.
Craig Dorman, North Star Mutual.
Denise Matthews, NEIC.
Right, back to that next table.
Holly Crocker from the Insurance Department.
Stephen?
Stephen?
AAIS.
Joe Willoughby, AAIS.
Jim Baranowski, the Hartford.
Mike Andrews, Insurance Department.
Janelle Middlestead, the Insurance Department.
Brian?
Brian Hoffman, Drivers. Tom Jennings, AAIS. John Wood, with Lobbyist, or Steve Martin.
Housing Director from the Insurance Department.
Lori Mine, AAIS.
John Reed, AAIS. Chris Hoffman, P, Insurance Department.
Joan and...
Kevin Rubin, AIS.
So, okay, I think so everybody kind of has a mix. You know, I know you guys have probably seen in the first couple of slides the Hartford and Travelers and State Farm's logo up there. We've had a lot of conversations with those companies, and so they really kind of got to start on looking at the technology internally. We didn't choose big companies for any particular reason other than Lori knew Brian really well, and Truman and Jim drink together. So
Jim's got a whiskey bar.
Yeah.
Makes whiskey and beer, so in a restaurant.
And you know, just trying to make sure that, and again, AAIS has a lot of smaller and mid-sized companies that are members. Our board members are generally from, and North Star is one of our board member companies. So we kind of run the gamut on companies that we represent, but we really do. I think we believe, and that's why and I think the commissioner also believes that it doesn't mean you have to have big companies. Collaboration means you have everyone in the room. That's why the NAIC is here. That's why the states are here. You know, Connecticut will probably, if this is successful, Connecticut will probably go next in wanting to work on a data call with us around openIDL. So it's not, we have to have everyone in the room, and we have to have, we want to make sure, because for the most part, AAIS has had very small and mid-sized companies, especially on our personal lines side, and we believe that you know, a healthy and strong marketplace has representatives from all sizes of companies doing all different things, and that I think most folks really have a value statement to their organizations. We just want to help you make a value statement out beyond that, so you can keep doing what you do, because you do it well. All right, so yes, ma'am.
Just to add on to that, and Truman will talk about this, but I've spoken about it in the past, is that when we looked for a blockchain solution, we knew that was the direction we were going with. Open source was critical to that, because the smallest carrier and the largest carrier need to be able to use the platform. We could not select a platform that had a $50,000 a year licensing cost to bring up a node on the network. there are lots of really great blockchain technologies out there, but an annual licensing fee that kept the smallest carriers from participating, that's another factor. So not only was open source a way to provide solutions to small carriers, it allows us to continue to grow it, to grow our platform. It's, again, inclusive. So many of you, and I know State Farm and the Hartford and Travelers may have multiple blockchain initiatives, and they may choose certain platforms in the future because it has a unique purpose. But core to openIDL is we're building a network for the entire industry, and it has to be inclusive. And so when we talk about the solutions that we come up with through design thinking, that's always at the heart of what we're talking about, is not only the platform, but the cost to participate, the cost to build things, we think of the industry as a whole. So hopefully everybody feels that they can participate.
Okay, so now we're going to move on to what the heck did we build? But first, I'm going to let Truman introduce himself and give a little bit of his background because it's important.
Cool, so thanks again for coming. My name is Truman Esmond. I'm the Vice President of Solutions and Partnerships at AIS. Joined AIS shortly after Joan joined about 7.5 years ago. My background is in technology and development and marketing and art and whiskey and some other things. So it's a very varied background.
AIS runs on beer.
Definitely beer. Moving trying to get label out on the carbs, cut those down a little bit. But before joining AIS, I was doing application development in a variety of different industries for a variety of different purposes. Everything from selling and activating cell phones online to fish tacos to executive information systems and hospital management systems and all kinds of different types of things. And one of the things joining AIS was really exciting about to me was that finding this organization that really supported just about everything we do. You know, insurance doesn't drive anything, but it supports everything. And when we talk about data and the data strategy about how all this needs to work together, it's a really interesting confluence of events and stakeholders to create something that I truly think will change the world. So I start a lot of my presentations or conversations. I'm a bit of an antagonist. I think we solved data privacy. And I haven't had anybody be able to knock me off that stool yet. So I start with that big goal, and as we go through this, I want you to think about what that means. Is if we did solve data privacy, if you can keep your data close to the vest, not share with anybody, but still have the rest of the world interact with that private data in a way that benefits you, what might that mean? So think about that, kind of file that away for a second. But we'll talk about that in the context of something very specific. So we're going to get into the weeds a bit on what is statistical reporting and what that process looks like, and how we solve data privacy for this particular use case. In this one case, we brought trust into this one particular use case of data interactions that drives, as Joan and Robin were saying at the beginning, everything we do as an advisory organization, which is one of the fundamental streams of our property casualty insurance industry. Hopefully, through this exposure to the architecture and what we're doing, we can see how that'll apply to far beyond just property casualty, but into certainly life and health and into all the industries that we support around there, certainly from a regulatory perspective, but also in all the other third parties that we need to work with for data interoperability. And certainly in insurance, those places are really obvious, from reinsurance and brokers to agents, independent agents, even policyholders, as those data feeds are going to be becoming much more real time from devices like your iWatch or your phone. And as an insurer, working with somebody that's driving a car for hire or driving a car to pick up their kids from soccer practice are two different insurance scenarios, and we need to be much more nimble and responsive to that in a trusted way. So that's what we think we've got at this point for the purpose of statistical reporting. So openIDL is the Open Insurance Data Link. I think we've mentioned that once or twice, but as Joan mentioned, it's the only property casualty insurance network that supports the insurance ecosystem workflows, starting with statistical reporting, with built-in data controls and optimum security. So it's not about building the walls, it's about making sure that the data we're using to make these trusted decisions, as regulatory policy, as underwriting decisions or claims decisions, or capital management or accountability to our delivery channels and the agents, bringing accountability to those data flows. Right now it's not a question of trust, it's just a question of doing it. Is it good enough? But in the future, we're going to be able to trust these these data streams in a far more flexible, timely, and important way.
Okay. So take a breath.
Okay.
You know, when and we've talked a little bit about what is openIDL with Joan's discussion. But let's step back a second, because I think we have people from kind of all over the spectrum of understanding blockchain. When we walked into this project, what was blockchain to us? I mean,
So-
what was it we were attracted to?
So years ago, when we first started hearing, about Bitcoin out in the world, and what resonated in my head that may be something very important to us was that when blockchain was first came out, and even when Bitcoin first came out, the tagline was that blockchain is a disintermediating technology. I said, wait a minute, we're an intermediary. That is what we do. So, and most of us are what we do as brokers and agents. Everybody in the industry is an intermediary to some degree or another. And we're always looking for solutions to cut that intermediary out to make things more efficient, automate that process, right? Well, if that's what blockchain can do, then how is that relevant to what we're doing? And that to me was struck a chord. Now, when we started looking at it, even it was a while ago, 4 or 5 years ago now, the technology wasn't mature enough. Bitcoin was really the only kind of example that was out in the world, and it really wasn't. Its model wasn't relevant to what we're doing, but the technology underneath it that allowed that immutable ledger, that data integrity underneath the hood, was really something critical. And if we could do that better, as John was saying earlier, as an intermediary, our job is to keep those data streams moving, help the industry move, expand, provide more insurance value in a nice, deliberate, data-driven, and stable sort of way, so that we don't create any risk for, or more systemic risk for across our jurisdictions, but we can cover those new risks and keep those products up to speed with what's happening in the market.
Okay. So I want to cut back, and we talked about Hyperledger, right? We talked about what that fabric is. And when we first walked in, we had some choices to make. Talk a little bit about the Dakota platform, the Ethereum platform, and their importance in this, and how that's merging together now with Hyperledger.
Absolutely. So following on the open source versus enterprise platforms, you've heard certainly Ethereum came out very shortly after Bitcoin and allowed a lot. It was open source, but it was privately sourced. It was foreign. Where that source came from was not transparent in terms of how it was governed or deployed out to the world. It was open source in that I could pick up that code and use it going forward, but the value is being able to have that underlying code be maintained and growing as the needs change, as Joan said before. As we find stuff we wanted to do, how do those features get incorporated into that core platform? So Ethereum had some nice things going for it in terms of that it was free or open source, but it wasn't quite there in terms of a trust platform. And when we looked at enterprise blockchain, we're not talking about mining for tokens and coming up with another way to disintermediate banks, right? We're looking at something different. So Ethereum didn't quite have the patterns yet. Corda was another one that came out, and that was built by the R3 consortium, largely a consortium of global reinsurers and financial institutions, around really one-to-one contracting and get some of these agreements in place. And it's a nice model for that, but it also is an enterprise price tag, and both has a very high dollar to entry. So some of our companies would be stuck with a 6-figure platform management tool, or a platform, an enterprise software tool. So that was a problem. And then further, the transparency of the technology itself wasn't there. So one of the things you'll hear me say is that you can't see all the way to the bottom of the pool, right? And when we're talking about trust, and we're talking about where you're going to put your data, and this type of a platform that will have inherent trust as a data strategy, that transparency's got to be there. You can't say, there's a smoke-filled room somewhere in the process that from a fear of a carrier perspective, you haven't given your data AIS. Your data is in your peer node, and we'll talk about what that looks like. But the rules that access that data need to be transparent and accountable. We can't all of a sudden, once your data is in there, change the rules that says, great, thanks for putting your data in there. We're going to go ahead and just hoover it out of there without your knowledge, or without you understanding what we're using it for, or without your permission. That can't be allowed to happen. The example going back from Hyperledger and Corda and Ethereum versus the Linux and Microsoft argument. I say a lot. It's like we're giving away free tanks, but then the question is, I don't know how to maintain a tank. It's like, we don't know how to maintain a leaky station wagon either. But this is the way that's going forward technologically, is open, transparent. It's something that we can build together and bank on, And from an efficiency perspective, again, it's free. You know, we have these conversations about what we could use or what the core underlying blockchain technology should be. We can always change it. It's just a function underneath the hood. You know, we can change it like we can change any other aspect of the technology stack. But if there's a better choice, there's no reason to change it right now.
Right.
Free, open, transparent, trusted, broad community gives us what we need.
Now, Ethereum had something going on from the very beginning called smart contracts.
Yeah. So,
Talk a little bit about what a smart contract and
So-
how that's relevant to us.
So, there's a couple of things that are fundamental to the blockchain technology. When you talk about distributed ledger technology, there's the ledgers themselves, which is really the fundamental piece of the data integrity. Smart contracts are how those ledgers get updated or changed, right? So if you've got an immutable ledger, unlike a database, you can't go back and delete entries or update entries. Just like in accounting, you put an adjusting entry or a new entry at the top of the ledger, and that will give you a current picture of what the history is. Smart contracts allow the interaction to that ledger. So how does a new piece of data get added to the blockchain in a way that we can then trust it? So it's not only does it have to be in the right format, it's got to come from the right place. Is that coming from the policy administration system, or is that coming from somebody manually entering a number on a form? That's a very important distinction about where that data is coming from. How frequently is it coming in? Is it coming in from a certified server, or is it coming in just from an open API and a public trust? So those types of things, not just the format and structure, but the trust score is very important. When we talk about smart contracts, it's not just, you know, I sell you this, you give me money. It's the entire process of how the data is brought into the system, and this is what we're going to talk about here in a second. How it's brought into the system and maintained its residency. So once it's in the system, it's trusted, and then once it's trusted in the system, how can that be used in multiple ways, not just for regulatory reporting in our case, but in other ways that can be used for purposes that data is trustable enough to be used for. It's enough for regulatory reporting, maybe enough to issue a policyholder notification, it may be enough to update a marketing strategy, but it's probably not enough to parametrically pay a $250,000 claim. Or things like that. So we've got to understand those types of things. So smart contracts is just computer code. It's not, as Rob will say, it's neither smart nor contract. But it's just computer code. It's just language that says when this happens, do this with this data. Data comes in, run these tests, put it over here. When data is requested, do these functions and execute it. And the key thing about smart contracts in that code is the code is transparent and it's distributed. So unlike today, when we do stat reporting, you give us, carriers give us the, not raw, but the policy level and claim level information. And so we know what that experience is on a carrier basis, and as the trust intermediary, you trust us to keep that information private, and then we aggregate it and send it up to regulators. In the future, you don't have to give us that data at all. In this architecture, your data remains private. We don't know what's happening at a policy level or a claim level information. We know what your experience is in the zip code for fire loss and what your experience is in the zip code for fire loss, and then we can take that information and summarize it using smart contracts to have a transparent answer given on trusted data to regulators without describing or without revealing any of the underlying private data about policies or competitive information or distribution or concentrations or anything like that for the purposes of understanding what's happening across a market or a jurisdiction.
Right. So we're going to use a term called extraction pattern in this, so kind of transition to what that is, considering you just talked about smart contracts.
Right. So an extraction pattern, or what we also call an interaction pattern, is basically a query. For database folks, it's just a query of how you're going to interact with data. What are you going to ask of that pile of data? What are you going to ask of it? And what we're using it for, that's a piece of a smart contract that allows us to query the data that is in the field across all of you. If each of you have a server with your data on it that's in our distributed network, we would execute an interaction pattern or an extraction pattern that you permit that would say on December 31st, for example, we will give the regulator our current total policy count of home daycare policies in force in North Dakota. And we'll get 12 from you and 27 from you and 175 from you. And then that number will go to 572 to the commissioner in a nice timely fashion. And that extraction pattern is what you will see to say, yes, I will allow this extraction pattern to run, and we'll actually show examples here of exactly what data is touched, what functions are performed, these numbers are added, these are averaged, those kinds of things to report to get to this final number of aggregated information for the regulator or for capital allocation or for another purpose.
Okay, so I think that's kind of giving everybody kind of a level playing field on the basics of blockchain and some of the terminology. Can you think of any other terminology you're going to hit that you?
If we hit anything, please feel
Yeah,
free to ask.
if you're like, what the
This
heck is that?
It's okay, there's no,
Go there.
like, the worst question is one not asked, right?
Right,
So-
right. So, all right, so this is going to seem a little out of sequence and probably is as we think about it. And some of you guys are sitting here going, okay, you've got this one use case around statistical reporting. Why the heck do I care? And, you know, I wanted to kind of bring out the relevance for even when you don't think it's costing you anything, it's costing you something. And some of, this was a report, and you can download it. The site is there. But basically, you know, you're spending money on compliance, and that's only going to get more expensive. This is a little bit dated in the 16, 17, I think was the 16 was when we saw this. But basically, you know, smaller carriers actually carry the bigger portion, and, you know, while 0.45% of direct written premium doesn't sound like a lot, it's still a cost you have. And quite frankly, I think it's conservative because, you know, it ties directly to your licensure, right? You cannot be an entity in the state you're licensed in unless you, in some level, and then those county mutuals and others have less reporting requirements and less burden at that. But at some level, you're paying to have that license, right? You're paying. There's money associated with what you're doing to maintain your status as a carrier. And so some of that is starting to get more and more burdensome. So that was part of the reason that this use case was attractive, because it's costing you more and more money and you get very little value from it. And guess what? The regulators weren't getting any value from it either, in a lot of senses.
So we learned a lot through those sessions.
Yeah.
You know, some funny examples that maybe weren't so funny in hindsight is that when a data call is created, we were told by a regulator that they don't know how to turn them off, for example.
Well, once they get embedded in your statute, it's very difficult to go back to your statute and say, yeah, we don't need that anymore, right? Brian?
And to add on to that, Robin, I think, you know, regardless of what the expense is, it is, it's definitely is expensive, but being able to redeploy folks away from that and do other things with the data or other things with the company and with regulators doing that is a significant cost.
And these are people like data scientists and data huntresses.
Huntress, yeah.
And, you know, and data wranglers that are really important in organizations today.
Those
You
are
know,
titles now, guys.
Yeah.
Data huntress, data wranglers. I personally am going to go with legal empress on my business card next time we get them printed.
And I think, Jim, how many regulatory reporting, individual reports did you share with us? I think over 1,000 of them were built up inside the 100.
Yeah, I don't know if it was 1,000, but it was pretty close over the last few years. I mean, one of the things that was interesting from design thinking maybe a year ago or so was we had Leo from California. We were just trying to come up with what's a real world example to where this would be possible. And it's like every year there's a wildfire. And every year we issue another call, and it's just in a different calendar, a different zip code. And then it happens, unfortunately, 3 weeks later. And it was, they issued it, we all had come with that data, everybody had to write it, but if we just did it by a smart contract that was written for everybody, that code's already been deployed, and then we all, you know, benefit from the savings of that. So it was a great timing, like unfortunate tragedy, but great timing for what we were trying to do here. So that's what really got, you know, myself and a lot of other people that I've talked about excited, is like, these are things that happen every day. Every day we get another request, we need another piece of data, and all of the carriers have to provide that, you know, to fall into that bucket. So that's what we're trying to do here. You know, I can talk a lot about my experience, you know, from the last 18 months, you know, with the group, on where we want to go, and some of the benefits of the technology itself, not just for regulatory reporting, but I think about, you know, how can we leverage the platform of sharing? And I have so many use cases that I want to see, like our company do. Some I'll share, some I won't, because I think this is a competitive advantage.
Yep.
But just on the sharing of data between it, and Joan and I have said this for a while, it's like we don't transmit data anymore, it's like consent. It's like consent to share just the portions of data that we want to, and I think that's the key of the technology. The security portion is what I sold like our senior leadership on, and that's what I really believe is going to change the way that we all do business.
Well, I think, you know, the cyber issue, I mean, big, small whatever size company you are, you've got to be concerned about the security of your data. I mean, you cannot ignore, I mean, there's a lot of regulations coming down on what you got to do to secure it, right? And that's.
Not as many as there should be. But
Well,
yeah.
there's not, that's not gonna, that, you know, small companies are not gonna be exempt from having to make sure, because let me just tell you something. If you got a 75-year-old grandma whose bank account gets exposed because of your system, it's gonna be your problem. And it doesn't matter
Especially if
how
you're
big.
also the insurance company behind it, too.
Yeah, and yeah, if you're insuring a company that had a 75-year-old, but you know, your data's, you know, the ability to protect and serve your customer is key to that. And we have to, everyone has to be diligent, and that is going to be a rising cost over the next few years as well for our industry. All right, so let's get into the real architecture, because I know you're just dying to understand it and know what we built.
It's not as technical as we'll get. Right?
Yeah.
So,
All right, so let's start, Truman, with some of the basic about what this is. So tell me what a node is and how it's operating in this system.
cool. So I will try and do this from here. So each of the boxes on the corners, the blue and the green and the pink, I guess, are all nodes on the network. So servers in across the blockchain network, they each, as you look at the center of the diagram, they are all participating in the blockchain network that is driven by the Hyperledger fabric, and each of those nodes has a peer that is a peer on the network, and they have that by sharing a channel on the network. So that's the actual ledger itself, the blocks that are being created and shared. And as Joan said, and we'll talk about this, it's not the raw data itself, it's that the evidence of the data exists on that peer. So we've got 4 different peers in this very simplified diagram. The blue ones on the left-hand side represent 2 different carriers. The ones on the right-hand side represent a multi-tenant carrier, and this is the AEIS when we host this function or host a node, continuing to act as that explicitly trusted intermediary on behalf of multiple carriers. So we will operate a node. And then the analytics peer, and this is the output of the data once it's collected and aggregated and ultimately disseminated back to both regulators and the industry. So they're all the same technology under the hood, but these nodes are doing different things, and they can be deployed for those different roles by any member of the organization. So, for example, inside a company, you could have a data peer, you could have a multi-tenant peer hosting all of your maybe independent agent organizations or your supporting companies that are writing different paper in different states. And you could also have an analytics peer that delivers information back across the organization, so without even connecting it to the broader network. And your data can still have that sort of integrity. Very helpful for things like mergers and acquisitions, and other different new product evaluations. So, but when we look at what is actually going on, and I'll can't zoom into it. What's that?
Next slide, I think we'll actually do that, what you want.
We'll go through the data call example. So
Yeah.
there's 2 on each peer. There's 2 kind of tracks. The first one is actually getting the data into the node itself, into the peer, so that it's resident and available to respond to data calls. And then there's the actual data calls themselves, and we'll walk through that.
Let's back up real quick. So let's talk about the integrity of that node, right? Why is that important? What's happening over there that makes this different from just me putting it in my warehouse?
Yep. So the first thing is that this node, this server, it exists wherever you want it to. In whatever cloud environment you want. It can be in your basement or in your data center.
Hillary's
wherever you want it to be.
bathroom.
So it's your control. So you put it inside your fort wherever you want. And then to the data integrity point, what's different about this from a traditional database is that as data comes in, and we'll go through this in a little more detail, coming in from your policy administration systems, your financial reporting systems, your claims systems, that data is coming in and being ingested, tested for quality, tested for accuracy, tested in any way that we possibly can, and then it's brought into what we call the harmonized data store. And this is where the data standards are codified into data that's stored into in this case, a NoSQL database. But the data comes in there and it met those quality gates. It's of the right format. It's of the right frequency and metrics. It came from the right places, and then it lives in the harmonized data store, so it can be used or activated for a future use case. So when the data call comes, so that data is resident. So your policies and claims experience is being updated as a kind of a snapshot in this world. Today, statistical reporting is done on a quarterly basis and then annual. One of the simplest things we're doing is asking for that to start coming in on a monthly basis. Most cases, that's already being generated by, every month, and we just get 3 months worth. But if that data goes into the harmonized data store in a trusted way, where you've now got a 30-day, window of data that can be trusted, now that can be used for much more things. A quarterly policy snapshot may not be that helpful, but a monthly policy snapshot can be very helpful when you talk about things like proof of insurance, or other sorts of allocations, commissions that are something like that might be paid on a monthly basis.
Okay. Now, let's also talk about, when it gets into that world, this harmonized data store world inside my node, and it takes on a certain characteristic, then how's that communicated on the blockchain?
Right. So when that data comes in, every time, so that let's say that month's batch of policies and claims data comes into the system and it's verified as coming from the right places, it is hashed, or basically a mathematical equation is run to take evidence of that data, a thumbprint, and that thumbprint is what's put on the blockchain network and shared, in this case, with the AIS peers, not with other peers, but that's the evidence there, so that we know that that data that's in there, that has integrity. It's been hashed, or we have that thumbprint of that data, such that when we go to query that data in the future, we know that the data that we're getting the answers from hasn't been tampered with, right? So we know that the information that was put in there is the same data, even if it's been updated, again, through smart contracts, just like in a ledger. Yep, we're updating our inventory and it came from the right place, so we know that's how many we have. So when that data is being queried to say how many of those home daycare policies are in force, we know we're getting an accurate quality number because the data that we're querying hasn't been tampered with. If it's been broken, we know right away. If that data's been tampered with, we say, whoop, hashes don't match, your data failed, basically.
Yeah. So once it comes into this environment, in this node environment, we're gaining immutability, because
Yep.
it's getting an identity of its own at that point, and it's being hashed to the blockchain.
Yep.
Okay.
We've passed the trust gate, so we've got immutability, we've got a known standard in terms of structure, so we've got a schema that we can query, which means we can ask a question of that data in a real context, not in an assumed context, right? So whenever there's a question asked, there's a lot of assumptions that happen, like even when you know.
Right. When you get your data call, do you sit there and go, well, what do they really mean about asking for this particular element? And I know that, as these are developed and looked at, new data calls and things that are coming out from states, and sometimes, and the NAIC's participation in that, you really struggle to get down what is the most common element, right? That we're asking for, that everyone can identify. And there's still some assumption that's made by the company on the part. So that's taking that away, right? We're going to leave that environment of you trying to guess what they meant, and them trying to anticipate what you need, and move to a system where this data is there, it's been identified, we know what it is. We can't see it, but we know it's there. And it's never going to change. At least that snapshot of it gives me that immutable record that it's not changed, right?
Right.
Okay.
And on top of that, the things like the smart contracts that are also immutable and transparent will provide those common definitions of, when we say home daycare, that means less than X number of square feet, means same structure as a house. Those common lookups and definitions that, again, are oftentimes assumed that one company's home daycare policy may be very different than another company's home daycare policy. A definition of a home daycare in North Dakota may be very different than a definition of a home daycare in Illinois. Mm-hmm. And we need to be able to take those into account and then be able to provide a broader picture of both across states and for the programs that are working in each of those states. So.
Yeah. All right, let's walk through
Right.
the AAIS openIDL use case for data, regulatory data.
So as much as we're talking about the technology, it's actually not a very complex process that we're going through here. There's really only 3 phases. There's the data call prep. So this is something that is happening typically inside the regulator's organization. A question comes from the legislature or the governor, or needs to be responded to in terms of an event that's happening. And the regulators will prepare that data call. Once that data call is issued to the market will review and look at that data call and consent to participate in it. And then the data call actually executes, and analytics are provided back to both the regulator and to the industry to actually get the result of that. So pretty straightforward. We'll talk about how that actually happens in terms of the data lifecycle, and then we'll actually go through, I'll take a quick break, and then we'll go through actually how this works from a user experience and what it will look like to you as a regulator, to you as a carrier, and even to us as AIS if you're interested.
Because it's all built, it's not a nice white paper,
No,
it
this is real.
actually exists in real life,
Yep.
and we can show it to you.
Well, and not only we're going to show it to you, you're going to do it.
We hope.
Yeah, we hope, right?
Please.
So we haven't scared you out. So the data call preparation comes in, and that's where we define the information that's needed and really build some empathy with the market around the purpose of this data call. So historically, data calls were created, on the regulator side, not a whole lot of interaction. Maybe there was some public comment period available, but it really was not a lot of empathy to the process. As we mentioned, the process itself has been, more or less, I don't want to say abandoned, but it's not been very terribly valuable in the last several decades. So how do we change that? When the data comes in, as we mentioned, it's being ingested, the data call preparation, when the regulator drafts the data call, and we'll go through this process, defining a purpose, who needs to participate, what data is going to be touched, queried, what answers are we looking to get, how often is this going to be run, what is driving this data call, is it the response from an approaching storm, is it trying to get an understanding of an emerging risk like cyber or sharing, or is it just to understand what are the top 5 causes of loss in my state of North Dakota, which we'll find out. So those are the data call preparation, and as the goal, as Joan said at the beginning, is we're trying to bring value back into this operation. Not only are we doing the regulatory reporting to give regulators an idea of what's happening in their trends, but to bring this back to the industry and provide some value in this service, right? This aggregated information is not just beneficial to regulators, it can actually be very beneficial to companies and certainly beneficial to advisory organizations so that we can respond, so that you know what underwriting decisions to make in the future. We know where legislative policy is going to go. We know what products need to be developed so that we can manage these emerging risks. So that's the data call preparation. And once the data call is prepared, the regulator finalizes it and issues it and then puts that data call on openIDL, on the blockchain. That data call is, again, just like everything else, it's immutable, so we know that that data call is not changing in the future. And at that point, it's then published to the industry. What is happening while that data call is being prepared is that ingestion process. So let's say monthly data from policy and systems and claim systems and financial systems is flowing through this process of being, going from on-prem systems being ingested, going through the governance. So what are the rules? Is that zip code in that state you say it's in? Is that a legitimate configuration of that kind of policy? Those kinds of things are coming in. So as the data is brought in for quality, it's transformed into the right format. So you'll hear things like ingestion and transformation, ITL processes of bringing that information in to get it into the right structure. And then we call the blockchain transaction manager gives us that evidence. So this is when that cube of data comes in, we hash it, get the evidence that that data exists, and then put that onto the ledger, and the data itself lives in the harmonized data store. That's there, again, completely in the company's control. It can be used at that point for a variety of other internal purposes. Again, you can query that database and run analytics as a carrier all on your own in that phase. So the data at that point is resident in the node, ready to be activated for an upcoming data call.
Okay, let me
Yep.
go back and ask you a question, because I bet you guys have this question. So what if my systems that are feeding this ingestion mechanism, what if they aren't terribly current, or maybe I'm using an Excel spreadsheet? How do I do that?
It doesn't matter what these on-premises systems are, and again, we're dealing with members that, and different products even, that are managed in very different ways. Obviously, high-volume homeowners is usually a very robust system, data architectures and patterns. We do a lot of in the marine, and oftentimes cocktail napkins are the typical method of quote bind issue. So
Mr. Lloyd's was a coffee house.
So a lot of different systems out there, but the idea is that the information is structured. It's not everything about every policy. It's not every endorsement in the system. It's just what we need for the purposes, in this case, of regulatory reporting and what are the quality barriers to get in there. So it could be entered through a simple web form. I just sold another in the marine policy. It's this much premium. It's this type of risk, and da. Or it could be coming in through a feed, an Excel file, or an extraction from a policy administration system. But what it looks like from a technical perspective is basically just an API. So for those folks that don't know what an API is, it's an application programming interface. We'll see these, but all the websites and things that you're using on the web, all the apps that you're using on your phone, all have APIs behind them, right? So that the same function happens through a web page or your app on your smartphone or from a kiosk at the store, right? It's all running the same API, so you can know what the inventory is, for example, of those
Right.
shoes that you like.
Right. But the experience can be very different depending upon the company. It can be as simple as coming from your spreadsheet to, it could be Hartford's data warehouse that's enormous, right? And why do we want to get to the same page is that, well, Hartford put their data in their data warehouse in a certain way. It probably doesn't look anything like your spreadsheet or the Traveler's warehouse. It might have some commonality, but it doesn't have enough commonality for it to be shared, or the insights around it to be shared in any common format. That is universal for us. So anytime you're communicating outside of your organization, whether you're using your spreadsheet to do it or you're using your very complex data warehouse, it's all going to people who are then looking at it to go, well, what does that mean, right?
I have a question.
Sure.
Where are the data definitions and the standardizing the meaning of the data elements? Where's that happening in that process?
So that's happening in the ingestion processes. So basically the APIs that are bringing the data in through in here. So the ingest, transform, and the governance process is those smart contracts, if you will, that are bringing that data in. That's where that enforcement is being done, where the schema is validating that the data is coming in the right way such that it can then be resident.
So I can't tell, is that still is that off chain or is that?
So the which part?
Is that depending on the implementation that the carrier chooses?
No. The data itself is off-chain. Evidence of the data is on-chain, right? The key thing that to understand that we get into
the data hasn't gotten to the harmonized data store yet.
Correct. It goes through this process. The smart contracts are running to bring it in to make sure that it's of the right format, it's meeting the quality rules, it came from the right places, and it's being packaged up, and then at that point being put into the harmonized data store, and evidence is being put on the ledger.
Right. So my point being that the data actually exists in the harmonized data store.
Yes.
Correct.
And the harmonized data store is off-chain.
Yes, yes. It's behind your firewall.
Yes, but it's in I didn't plan on getting into this deeply, but that going back to this.
No,
This border here is important. So while the ledger is in here, the node is its own unit, right? So while the ledger, a lot of systems, and this is an important point, because when you talk about on-chain data versus off-chain data, the data that's not on the blockchain is at risk, right? You could have a fragile situation, even if you have evidence of that data on the blockchain, which is immutable. If the data itself exists in a traditional database, like it does in this case, that could be fragile. Somebody could go in, write a query, delete a whole bunch of data, change some data, and even though it's been changed or deleted because it doesn't match the evidence, you got a broken system, right? I've got evidence of data that no longer exists or that I can no longer trust. What we've got here in openIDL and the border that we're talking about here, this is actually an integrated system. So while it is off-chain, it is tightly coupled to it so that you can't be manipulating that data. Well, you'd have to go through some serious calisthenics and violate security policies in the system in order to break it, right? It's not fragile. It's not, there's very little risk of somebody manipulating that data outside of the context and creating a system that, while it may be trusted, doesn't ever work. So
yeah,
that's
good point. I mean, I see now, that, like you said, the dotted line around the openIDL and all those pieces.
Right, so that's the network, but each of those nodes is independent. So while we're bringing other technology into and existing on that node, like the MongoDB, like the IBM blockchain platform, like Hadoop, MapReduce, like all those things, we're leveraging.
Don't worry,
Kubernetes.
he lost me on
on
all of those.
All the
too.
different pieces, the stack of an application, are all running in a technology called Kubernetes, which is what Google developed and why Google is what it is. And that is also another open source and community-based technology that's being deployed from the Linux Foundation as well, or through called OpenShift. And that is how we can take this same thing, the same architecture, and drop it into your basement or onto any cloud, and it's exactly the same, right? So that it's through tightly coupled and trusted components or packages or containers in OpenShift and Kubernetes that work together to create this peer. So while yes, the data itself is not on chain, they are tightly coupled to create a trusted stack of applications to do
But I
this.
think it was that ingestion part and that transformation of that data from all these various
Yep.
Mhm.
Excel spreadsheets and all these other things that are taking place into the harmonized data store. Saying that sounds a lot simpler than it is.
It is.
Oh, yeah.
So, and the,
When
the
saying
most,
that, it's just all through an API.
yeah, no, and that's the most common question I get is how, yeah, go ahead.
Yeah, and we agree with you completely. So one of the things as we were developing the openIDL is we have got to get to the point where, the technology is not the issue. That's why we work really hard to containerize it. And Truman ran an industry test drive. It takes 4 hours to stand up a
Oh,
server,
not even.
load
You-
data,
yeah.
and create a report. We
Like the
worked
first time you're doing
really
your breaks,
hard
it takes 4 hours.
Right.
so that it is completely containerized. And we don't care about the underlying technology, we care about the data and how we use the data. And, to this point, IBM bought, they're buying technology because they also recognize is that what's important is what we build on top of it. So they want anything that we build, that say IBM blockchain platform, they want it to run in every cloud provider there is that can't be. When we first started, this was one of our pivot points. We created the system and we did load it onto Amazon, but we didn't like what it took to do that. And so we worked with IBM and said, this has to happen in hours, not days. It has to happen with systems administrators that are here. It needs to be containerized and secure because a lot of companies aren't going to have a suite of security experts to monitor this. And so that's why it's all wrapped up in one box.
Right. And the, again, what you're using this box for, even the 4 boxes we have here are for 4 different purposes. An individual carrier or reporting solution that once it gets to this point, it's all anonymized and aggregated data. So that may not need to be as hardened, for example, as the private proprietary data that a company's feeding in on a much more regular basis, right? So like in any system that we build on the technology perspective, it's not going to be perfect. So how do you make it perfect enough to suit the job? We need to trust it so far. And in this case, for regulatory reporting, we know that it needs to be trusted in a certain degree, and it's all completely within the control of the carrier to create that mechanism that suits their needs, how much they want to protect it. State Farm will probably want to protect their proprietary data that represents the bulk of homeowners, maybe far more than somebody with a dozen or 2 policies.
Right, but a company like Chubb, they have a real market around high-value
High
homes.
value.
Are going to want to protect like what that book is, right?
Yeah.
So they have to have the ability to do so. Same for your smaller companies, right? You have a niche market, or you probably, that you've been serving. You don't necessarily want to give away all that secret
Right.
sauce, right? That we get it.
And volume may be your secret, probably not, that's a regulatory thing, but location is probably secret. Concentrations, those are proprietary, you don't want that getting out.
Yeah,
But
yeah.
you want to know, and, one of the things we say is that those, regardless of your size, those sort of metrics need to be obeyed in the future as things become much more
But you're going to have to
rapid.
know and use and leverage that data regardless of how proprietary it is, right? There's got to be some part of that you have interaction to other data with, so.
Cool, so we talked briefly on the harmonized data store, and one thing that we haven't hit on yet, that Joe will go into in more detail, is that the harmonized data store has a target for data. So as we say, I'd really love to have some information around sharing or cyber or some new thing, we've licensed the IBM's IIW, so the Industry Information Warehouse model for insurance, and that creates us a north for a broad target. This is a database schema, a warehouse schema that's been developed over 30 years by some of the largest insurance companies and insurance-related companies to create a very comprehensive data standard. And what we've done is create the regulatory reporting data model that references or maps to that. We have an open source model for regulatory reporting that maps to a proprietary model, but as we look towards expanding the model, we know from a framework and a point of reference where we can build from. So Joe will get into that in much more detail, but it's really important to understand, because the hardest part is how do we get started? And the answer I always give to folks is how well do you know your data? If you don't know where your data is, this is going to be a challenge. But for some of the things we'll talk about today, I can tell you where it is if you do your statistical reporting for AIS. It's these data points over here. If you do it with ISO, it's these data points over here for this one thing. Yeah, Joe?
And the other key thing about the IIW is that if some companies pay over $1 million to license this software. The biggest companies in the world, they're happy to do that, they contribute intellectual property into that data model. And the industry as a whole can't license the IIW, it's just cost prohibitive. So AAIS negotiated a contract with IBM. We have access.
25 years later, right?
Yeah, so we have access to that model, and we are creating the regulatory reporting data standard from that model. There are data definitions, the way data relates to one another, but they allow us to publish that as an open standard. It took us months to work through this, but we said, no, we're open source. The only way this works is that every carrier in the country can look at the model and put data into a repository according to this model. And eventually said, okay, we get it, yes.
And like other standards, as that becomes codified and used, it's being used right now. That standard is being used by the, tens of billions of dollars of regulatory reporting data we get every year now. And it maps to that. But it needs to be expanded and moving forward, so.
Okay. Yeah, let's
All right,
keep
pick
on,
it up,
because
right.
Joe will talk a lot about the data standard and why how that
It's really,
works.
really important.
He's only going to talk this much about
Yeah,
it.
I'm gonna leave in like 30 seconds. So then, once the data call is issued, the data is into the harmonized data stores resident in each of the reporting carriers. Then the data call is issued, and that the interaction pattern or the extraction pattern is activated. So the kind of starting from the top here, the interaction pattern fires. So let's say this is our, what are the top 5 causes of loss in my state by year. This is going to fire at 12:01 on January 1st of the new year. That will trigger. The blockchain transaction manager takes the queried information. So we'll show you an extraction pattern. It queries the harmonized data store to say, give me the total policy count, give me the average, things so we know where the top 5 causes of loss are year by year for the last 5 years, let's say. And take those totals and averages and take that as a cube of metadata, so answering the question, and taking that cube, putting the evidence of that cube of data, the answer to the question, onto the peer, so we know that the response has its own integrity. And it uses what's called a private data collection, and this is part of the Hyperledger fabric, part of the open source software underneath the platform that we're leveraging. That information goes on the private data collection and then is shared directly with AIS through a different protocol. So it's
Off-chain.
So to Denise's question, is technically off-chain, but it is part of the blockchain platform itself. It exists in the same, as a kind of a sidecar to the ledger, so that we can keep the ledger nice and light and performant and be able to get rid of this data after it moves over. We need to know the data has integrity. We got it. Great. We don't need to maintain the copy of the data after that movement.
Right,
So-
because say if I wanted to recreate that,
Yep.
I'm just going to be looking back at the hashes that evidenced what that was to get the answer again, right?
Right.
So I don't need the data sitting off in a just separate place outside of my organization with people that I don't know if they're going to have it secure or not. And think of all the applications that could impact for you. But then that can go away.
Well, yeah, and
And
there's two.
and the evidence it went away is written on the chain, right?
And there's two cases in there. So we think we've solved GDPR as well through this, because what Robin just outlined, being able to ask that question again, we know that we got the answer this time, and we have integrity in an audit trail that verified that the answer we received was the right answer. But if we run that again, there's no guarantee that the underlying data didn't change. Somebody said, I canceled my policy, exercised my right to be forgotten. As a result, when you ask that question tomorrow, you may get a different answer, right? Somebody said, I'm out. That policy is no longer in force. So you may get a different report, but you know exactly why. This person canceled their policy, exercised their right to be forgotten, and that's why it's $5,000 less on this report. But we can prove that, and we know why we got there.
Right.
But we don't need, after the first quarter of 2020, we don't need to carry that data around anymore. We can wait, now we can look at the first half of 2020, for example.
Now, let's kind of take this a step further.
Right.
Eventually, do you need us over there in that analytics cube?
Nope. So we've disintermediated ourselves at this point. So for the things that are ongoing regulatory reporting sort of duties that are call it the rate updates sorts of reporting that we're doing, we're out of the picture at this point. We don't need to do anything. All we're doing is basically making sure the process doesn't break and maintaining the network system and the rules that are around that as they change by regulators over time are communicated and codified into the system. and transparent across the platform. So we
And that's
don't
not
do-
AAIS, that's the community
Yeah,
that's
it's done.
doing that at that point.
So
We're done, right?
The other folks that are out there that do stat reporting and that's it, this just automated that. That function is no longer needed to be done. The additional things that we would do that now, to Joan's earlier point about the internal versus the external data strategy and what an externally focused data strategy is for AIS, now we're looking at the new data that we need and the new rules and the new information that we need to provide the information back to you as the industry of what to do. How do we handle sharing economy? How do we handle automated vehicles? How do we develop policy to see which roads an AV can drive on? How do we do licensing for drones, in city, things like that, and tracking those. So all kinds of fun things that can be done there.
Yeah, but we basically took away the need for there to be someone standing between the regulator asking the question and you as an industry giving an answer.
Focus
Don't
on the
need those
things that are
anymore.
changing and adding value tomorrow, not the things that are just, kind of set in motion yesterday.
Yep. Okay, let's keep going.
Keep going. So, all right, phase 3, the data call analytics. So once that data is gathered by AIS and assembled, and again, additional quality metrics are put together in total, we can compare against industry data to know how much data we actually have, if things look right. We take that information and it is redeployed back into another node, another environment, we call a pop-up analytics environment. So all that anonymized, summarized data is deployed to a node, and then we can provide a visualization to not only the regulators, but to the industry around what that data says. So you can superimpose, and again, we'll show this a little bit, what the data looks like in general, so you can see zip code level information about fire losses, those top losses. But because you can see your information in addition to that, you have an overview of
Where
how
you
you're doing.
sit, right?
Yeah, how
Where
you're
you
doing.
are in the scheme of everything that was reported,
Right,
okay? So you're kind
yeah.
of seeing your performance.
Right, you can see the temperature of the zip code, and then for each of your houses in that zip code, you can see if they're above or below average temperature. Is this, for example? Because nobody else can see those houses, those individual properties within the zip code, except for the data owner of those policies. So, and we'll talk a little bit more about that, but that's where this is deployed. And now, once it's in that environment, that data could be brought in and tied to, for multiple perspectives, other sources of information, weather information, catastrophe models. So you can see which of the 5 catastrophe models best represents your loss history, and therefore may be the best predictor of future losses. You may be able to use multiple models one for fire, one for crime, one for flood, one for catastrophes.
Right. And the other part of that is that because it has a transparency to it, the regulator can also look at that. And we struggle right now with bringing new things into our industry, like IoT data, and there's big debates about about review of models and how does that really impact the company that's using that, so that they can judge, is it does it meet the parameters of what is not unfairly discriminatory, inadequate, or excessive, right? That's their jobs. So it allows, again, the level of transparency back to the regulatory environment to judge some of these things as well. So that the things that they struggle with on being able to see into black boxes of models and other things, we start looking at the actual output. What did it actually do? And how did it actually interact with our company? What does this really mean to our consumer? Instead of trying to pick apart maybe the data model in itself and trying to test whether or not it meets certain standards. So.
Cool, so the next, we'll be doing a live demo, but I do need a couple of minutes just to get that set up. Been going for an hour here.
Okay, so I'm going to say 5 minutes because we'll have a lunch break at noon. But let's take 5 minutes. So Truman has to get all the passwords and stuff in.
All my logins
So
expired.
there's an actual website where we go in and show you how we do this data call. So take 5 minutes and let him get that set up, and you guys can talk amongst yourselves or take a break.
Ready?